Welcome to Utilizing AI, the podcast about enterprise applications for machine learning. Each episode brings together experts in enterprise infrastructure to discuss applications of AI in today's data center. Today, we're discussing enterprise projects and, frankly, why they fail. First, let's meet our guest.
Hello, and thank you for hosting me today. It's a pleasure to be here. I'm Roey. I'm BeyondMinds CTO and one of the co-founders. In the last 7 years or so, I'm doing research around AI, and in the last 2 years, I'm focusing around intersection of business and technology.
I'm Stephen Foskett, organizer of Tech Field Day and publisher of Gestalt IT. You can find me on Twitter at sfoskett.
And I am Andy Thorai, co-host, founder and principal at thefieldcto.com, home of unbiased emerging tech advisory services. You can find me on Twitter at Andy Thorai and at thefieldcto.com.
So I've been in the enterprise tech industry for a long time, probably longer than I want to admit. And, it's true that most enterprise projects fail. We've seen this, countless times through countless different technology trends and technology transformations. In a way, it almost doesn't matter what the technology is. You can guarantee that the majority of these projects just aren't going to work. Why is that? What is that that causes problems in the delivery of enterprise solutions? Roey, what do you think?
Well, I can give you mainly the AI angle of things. I think that it's important to observe that what we see in AI is significantly different from what's happening in the software world, which is much more mature. You can see different solutions that are off the shelf that are great and can solve different problems. But the situation in AI is completely different. And I think one of the main observations that I can discuss around this failure or systematic failure is the buy versus build dynamics around AI solutions. And unlike software, there aren't many off-the-shelf solutions that you can buy. And that force companies and enterprises in specific to build their own data science team, hiring people, starting to develop from scratch. And that's very complex. So I think that's an important observation that probably is one of the most significant reasons why these projects fail. So one of the most significant challenges in bringing AI to production is the need for customization. That means that problems in enterprise AI are inherently specific. If you have a specific problem that is unique for you, that means that you're going to develop, that you need to develop something that is dedicated for you. Significant customization. And without that, with this need, there is a lot of effort that need to be taking place there.
Well, so I hear what you're saying, but so it is different in a sense from an enterprise software that, there are, AI actually comes with two components. One is model training, which requires a lot of horsepower. And then there's model inference, which requires a little less horsepower. So you need to cater for both, because with the model training, it's the bulkiness, is the how deep, especially when you do a deep neural network, how big of a power you would need and how much of a data you would need is an issue. And then when it comes to inference, how fast can you do it and how close to the data you can be and how often can you update the models? Is that in itself is an inherent problem in a sense that, there are two different areas you're trying to attack?
Yeah, I definitely agree. So I would even say that the situation is even worse, because what we see in enterprises and in young data science team, that they look at AI solutions as a single model. Let's collect data, clean the data, go to their lab, train a neural network, pick our PyTorch TensorFlow framework, throw the data in, maybe tweak some architecture, design, bring a state-of-the-art open source research. Boom, we have a model, 95% accuracy, we are happy. But that's like probably 5% of the work, because then you need to take that model and put it into production. And there is a huge gap between this academic research and way of thinking in the lab and the real life environment with messy data, with real life noise, with production challenges, with cost-effective cloud, with the need for maintenance, the ability to do updates to your models, to your system, the way that you collect feedback, how you stop garbage going into your models, how you build a trustful AI relationship, how can you bound your results with confidence. So I think that taking what you just asked, I think that the right way to bring AI to production, that's focusing on AI systems with many components that need to be developed. So maybe like the most important tip that I can bring to data science team is you're going to have to invest a significant amount of time, effort, and money into infrastructure, systematic development, and not jumping into the lab and training a model. That's the possible part, but there is an entire system that needs to be developed in order to really see value from these solutions.
If you don't mind, I want to double click on that a little bit more. You talked about, building an infrastructure. Yes, the infrastructure part of it for the model training is a lot easier now with the GPU invention, especially, right? NVIDIA doing a ton of stuff on that, and the horsepower for the GPU is available, plus the compute power is available on cloud, that more than you can have at any given time. And the data lakes are gone into humongous data lakes that you'd be able to feed in on a constant basis and keep updated on a constant basis. So the model creation problem seemed to be somewhat, as you call the lab experiment, is somewhat solved. So do you think the actual problem is more towards the model inference or more towards actually making it production grade, or all of the above?
Yeah, I think, well, there are many challenges around AI to production, but if you want me to pick one, that's around the production grade, yeah, the scalability, the stability of the system, right? Let me give you a very tangible example from a real life scenario. So recently, I'm doing a lot around defect detection in the manufacturing environment. And that's quite a new technology that you can really trust about a machine to do defect detection instead of human in production line. But what data science teams see again and again in this production line is a significant drift of data. So you train the model again in the lab. Let's say it's an object detector that can detect defects in your products. It could be cosmetic defects or electronic defects or whatever, I don't know, defects over lemons in production line for agriculture. But then you see drift on the data, and that comes again and again and again, a new kind of defects. And suddenly the color of the product is changing, and the lighting in the room, the illumination is changing. Or I don't know if it's if you want to sort lemon to good lemons and defect lemons, and suddenly the season change and the lemons are not yellow, they're suddenly green. How can you collect that feedback from the user, retrain your models without forgetting what you have learned before, improving over time? And I would call it how to keep the train on the rails, right? You build a model, but that's now need to be deployed and impact over time. And I hear from data science team in this domain, lots of like heavy nights where suddenly the AI stop working well and they need to fix it. And there is nothing that AI team hates more than going back into old code. So that should be part of the system, right? How to monitor the data that comes in order to be able to alert the data science team something is weird going on. The data suddenly shift, and other factors, right?
So that actually brings to mind a lot of the discussion that we've heard around DevOps, because it's really, it strikes me again and again in these conversations that MLOps and DevOps are really facing the same sort of structural and procedural challenges, even if the technology is very, very different in the technological approach. And one of the challenges of DevOps for a long time has been basically to to get to the point where the people that are developing the software can properly understand and interact with infrastructure. And I see such a parallel with AI, because as you're saying, if you just dive in and you're like, we're a data science team, let's jump in, let's train our model, let's have our model do great things. It is exactly the same as a development team writing a new application without taking into account the infrastructure. So how do we break that wall down? I mean, because this is a wall that's outside of AI. This is a wall that happens in enterprise IT development all the time.
So yeah, DevOps and MLOps are part of the game. And I will say that in order to bring AI to production, you don't need only data scientists, and you need a corpus of different roles with within this team. You need the engineering, the backend, the front end. You need the data science team. You need researchers maybe involved. You need DevOps. So it's more of a squad way of thinking if you really want to solve all the problems. And I think at BeyondMinds we build our own ecosystem and understanding of how doing that. And I think a significant part of it is investing time and effort in solving some fundamental research problem along the way. Starting from different building blocks that you need for training. So for example, with our core platform or core technology, we build the ability to train in a scalable way, to hyper tune the parameters and different aspects that we need along this training. But beside that, I think there are many fundamental problems that must be solved and be part of the overall solution, part of the AI system. A very classic example that I always give is what we call the input gate. That's our garbage collector in the entrance to the model, to the system, right? Let's assume we want to build a classification network to distinguish between cat and a dog, right? What will happen if I will get an image of a giraffe, right? The AI model will say, this is a cat or this is a dog, what is more similar? And the problem becomes even worse because the softmax weights or the probabilities will be even high in many of the cases. So we have developed around a lot of IP and solutions around what we call out of distribution, or what the research community is called out of distribution detection. Basically the ability to say, wait, this is not a dog, not a cat, this is something else. Please call a human to interrupt here. And that's another part. How do you work in a human in the loop environment? And if you really want to bring AI into production in a mission critical problems, you must understand how to work with humans in the loop, how to build a trustful AI. And I think that's another important factor to take into consideration.
So I want to double click previous statement you made. That in itself is a classic difference between the way we build and deploy enterprise software and AI systems. A lot of people still don't understand that. The major difference is most of the other systems, whether it's DevOps or enterprise software or whatnot, you get the software and then you build the system, you deploy the system, and then the system stays in place unless you do some bug fixes or updates and whatnot. But with AI, because it's not system-based, it's data-based, which means based on the new data, as you are suggesting, it needs to update itself, which means technically any AI system should be capable of, going back to your dogs and cats reference, the system should be able to reference and infer and learn this is neither a cat nor a dog, but if you give a feedback to it as a, supervised learning, it should also say, okay, that's a giraffe. Next time onwards, I'll keep that in mind. So there's a possibility for an AI system to be doing both the supervised learning and unsupervised learning. So that's what makes it a little bit trickier for the AI in the enterprise systems versus other enterprise software.
Yeah, I agree. So we are clearly not in the stage where general AI is something even close to exist. So with the current state of AI, it must be wrapped with a lot of engineering around it in order to bring that into production. And how to collect feedback, validate on real time, and retrain your models with that feedback from the user without forgetting what you already learned. That's a significant part of any AI system that I see today. And I think what the main trend that we see today is moving towards mission critical areas for AI. So what we saw, let's say, in the last 2-3 years is mainly around use cases of AI where the accuracy is not too significant. Let me give you an example. So let's assume you need to do speech to text for conversation and then bring some insights from this conversation. And then let's say you have a corpus of insights, you do some statistics. It's not really important if you're in 85% accuracy or 82% accuracy. It's a statistical way of thinking. But let's now move into a classic enterprise use case in the insurance domain, claim assessment. You want to decide if to accept or reject an insurance claim. That's not statistical at all. If you will be wrong in one clear reject case and you will give it a proof, someone will shout at you and will fire the data scientist or will complain about the ability. So the confidence level that we need to work in is much more significant. And if you want to bring claim assessment into production, even if it works like 50% of the time, in this 50%, you want 99% accuracy. And that's requires system, right? You want to be able to have a confidence score and do some basic decisions about that confidence score. If the confidence is low, pass it to a human. If the confidence is high, pass it to the system, right? If it needs to be rejected, pass it to a human for a second judgment. If it's claimed that you haven't seen in your training set, pass it to a human. But it still will be able to improve 50% of the business. And around insurance operation, that means a lot of money. Even if it's 20%, that's still millions for a classic insurer in the US.
On that note, too, I think that one of the things that's come up a few times in this podcast is this whole question of sort of understanding, I guess, the limits of AI. It's seductive. We actually talked about that earlier. You can assume, wow, this thing is so powerful. It's going to give me such great results. But it's very important that data scientists and business people in general understand that this stuff is not magic. And even though we call it artificial intelligence, in many cases it's not intelligent in the sense that we want it to be. And so the examples that you're providing, I think, are very important because, for example, if we're doing insurance claims based on the output of an ML model, how do we know that this thing is responding within the boundaries that we expected? I think we can all guarantee that it's responding to the model in a sort of a predictable manner based on the data that the model was fed. But is that going to give us good results, or is that just going to give us results?
So I think you're touching one of the most important factors and topics in AI, and I will call it trustful AI. And I think it's combines of 3 main factors. The first one is what the community terms explainable AI, or XAI in short. And I will be happy to join a podcast only about that because I can talk about that for an hour for sure. But on a nutshell, Explainable AI means the ability to explain why something is happening, why this is the prediction. Going back to the claim assessment, why this claim should be rejected or why it should be accepted, right? And then you have bias mitigation, which is clearly super important factor in the world that we live in. And I can talk about bias mitigation as well, but I think it's an important factor even for the data science team and for the business team to look in a closed loop about what's going on around bias. Definitely if you're talking about sensitive data, sensitive environment around people and around data. And then the third part, which is critical factor in any AI system, is the confidence estimation, or the research community usually call it the uncertainty estimation, right? I want to be able to bound my prediction and understand when the machine is able to predict in a high confidence and when it's not. And that's a very basic question to ask about the machine learning model. So confidence is one part of it, the different types of confidence estimation. And maybe the second part is what I mentioned before, the input gate, which is some kind of confidence over the input data, basically. Saying this new data that just came, the giraffe image that I mentioned in the past, in the previous question, is that in my distribution that I saw in the training set? Because if not, I don't want to predict what's going on in this giraffe. Same to claims, right? If I trained on different claims in, I don't know, let's say medical insurance, and all the claims were around orthopedic, and then suddenly a claim from a different domain of medicine came, that won't work, right? So that's something that at the business perspective, or the product managers which build the AI product must understand.
Well, actually, almost at the 30-minute or end of the podcast, we are warming up with the heavy, hot and heavy topic. I actually wrote a piece on that about a year ago. This is one of the reasons why AI will not be mainstream for a while, because it's not exactly artificial intelligence we are looking for. We are looking for augmented intelligence. In other words, if a human can't make a decision, humans are allowed to make subjective decisions. Machines are not. And that's not going to change for a while. I mean, they can, but they can only help a human in making the decision by providing the data. So that's why the most major issue most enterprises face is that, when a machine makes a decision based on a data, it should be fed into when you need to escalate it to a human with a confidence score, and then assist the human making a decision. Explainable AI, trust in AI decisions, security, constant updation of doing that. These are all, each one of them can be its own topic. So at the end of the day, that in itself is the major problem in enterprise and production, right? It's about making AI-based decisions that will assist humans, not the AI by making a decision in itself. And you need to build systems for that.
You're definitely correct, and I read your piece, and it's a great reference. I think that's quite agnostic in most cases, but not to all of them. So you can find different use cases in AI where the interaction with human is less sensitive. For example, predictive maintenance, right? Again, in manufacturing, you want to be able to predict if something is going to fail. And that's very clear how to move that needle of maintenance, and how to prevent a sudden failure in the production line. Right? If you have a good way to predict anomalies in the way this machine works, if there is an anomaly, go do prediction, go do maintenance, right? And then it's less easy. It's more easy to move the needle there, to bring ROI to this company, to this enterprise environment, and it's not necessarily, let's say, heavily decision support around sensitive decisions, right? In the worst case, you did extra maintenance. Okay, so I think there are lots of heavy problematic areas where it's clear decision support. I don't know, healthcare is super complex, right? Insurance, it's starting to touch these areas. You see many, I don't know, fraud detection in the financial services. That's again, in the worst case, you block a transaction and the user will call you, why did you block my transaction? Or on the other side, they will say, oh, thank you for blocking that transaction, that was a fraud, right? So no harm have been done in the worst case.
I agree. It's there are a few factors in play. One is the sensitivity of the transaction. The other one is the value of the transaction, and ultimately what it decides. You can't let a robot decide and do a surgery on me automatically, even if I give a consent. So it depends. It's situational basis. You can't globalize the decisions, right? And also, I would argue, going back to your original statement, there are certain things human can never decide. For example, the predictive maintenance that you're talking about. There's no way in hell I'd be able to analyze all the data that's available. Even if I map a digital twin model, I won't be able to figure out when a specific component is going to fail. When I say I, not just me, but a human, because our brain power is somewhat limited, right? So you need some help. So there, whether you could say, okay, you can have a machine, look at this. This is a high value machine. I've worked in some of those use cases in the industry in that particular area. It would say, if the machine goes down, not working tomorrow, it's going to cost me millions of dollars per day, high value machine. So, this component might fail, high probability within the next 2 weeks. Let's order a replacement part. That can be automated. But, just dump that machine and buy a new machine, that probably may not be, the decision may not be automated. So it depends on the use case.
Yeah, definitely, I agree. And I think maybe if I can add another comment that I see very important in today's AI landscape. I think it's around what are the challenges of this time, right? And I think if you go to Gartner reports and different survey and others that are reporting what are the main challenges of today, I think they are doing post-analysis of what was true in 2018, and I see completely different challenges in 2020, in today. And I think it will take a year till you will find a report that is reporting that. I will focus about the ability to customize your solution, the ability to handle real-world data, that means production-grade AI, build trust that we touched, and create impact over time, right? How you build systematic solutions over time. And that's the area that I see all the time in companies. That's what we are focusing at BeyondMinds. And I think that's the trend that you are going to see in the coming year.
So talking about the challenges between 2018 and 2020 and going beyond, one of the things that most of the enterprises don't do properly is, how to allow your customize your solutions in production, particularly for AI, particularly for the models. How do you allow them to customize? Do you have any thoughts on that?
Yeah, I will say two things. One is vendor selection strategy. Mm-hmm. The basic understanding that a majority of what you need to solve, you can buy and reach ROI faster and cheaper. And you should build a strategy on how to select vendors and what to push out into external vendors and what to develop inside. Because clearly the domain knowledge is within the company, but there is a lot of expertise around technology out there that you must use. So that's the first thing. And the second thing, I think we touched it quite heavily in the conversation, is the basic understanding that AI is a system. And if it's a system, you need to invest a lot of effort and time in solving fundamental problems that will allow you later to bring AI to production. The fact that you have 10, 20, 50 PhDs researchers that just finished in MIT waiting to solve your problems does not mean that it will be easy to bring it to production. I can give you something that a quote that a client of ours told me a few weeks ago. To hire a data scientist today is quite easy, but to bring a data scientist that will be able to bring something to production, that's 1 of 1,000. And you want to minimize this dependency on the ability of the data scientist to bring something to production. And the way to do that is invest in the system, right? It's not only the infrastructure of the cloud, but it's the code infrastructure, the technology stack that you're going to use. And that's a different mindset, because think about this VP R&D or head of AI in a large organization saying, wait, I need only 10 people for a year and a half, 2 years, just to build infrastructure of code, of solutions before you even start to see ROI. That's a challenge. And this is why I think many of these challenges should come from outside of the organization.
I think that's a great summary and a great way to end the discussion. I am going to take you up on the offer to have a follow-on podcast where we discuss some of the details of making this happen. But for now, folks, this has been just a marvelous discussion. Roey, thank you so much for joining us. Andy, thank you for joining us. Before we go, please tell us, both of you, I guess we'll start with Andy and then go to Roey, where can we connect with you to follow your thoughts on enterprise AI topics?
Absolutely. You could follow me on Twitter at Andy Thorai or my website at thefieldcto.com.
Well, I'm quite easy to find online. My name is Roey Mechrez. You can find me on LinkedIn quite easily, and you can find BeyondMinds, BeyondMinds.ai online. And we will be happy to meet and discuss how to solve your problems.
Great, thank you. And I'm Stephen Foskett. You can find me on Twitter at @sfoskett, and you can find my writing at gestaltit.com. Thank you for listening to the Utilizing AI podcast. If you enjoyed this discussion, please do remember to rate, subscribe, and review the show on iTunes, since that does help visibility. And please do share this show with your friends. This podcast is brought to you by gestaltit.com, your home for IT coverage from across the enterprise, and from thefieldcto.com. For show notes and more episodes, go to utilizing-ai.com or find us on Twitter at utilizing_AI. Thanks, and we'll see you next time.